This distinguished-looking scientist is Dmitry Mendeleev. He is credited with developing the modern periodic table. Looking at the periodic table, we notice that most of the elements are metals, which are shown in green. Nonmetals are at the right of the periodic table, shown in blue. Metalloids form a sort of staircase between metals and nonmetals. The elements have both metallic and nonmetallic properties. In the periodic table, rows are referred to as periods. The columns are referred to as groups. Some important groups are 1A, the alkali metals, 2A, the alkaline earth metals, 7A, the halogens, and 8A, the noble gases. A molecule is an aggregate of two or more atoms in a definite arrangement held together by chemical forces. Hydrogen, water, ammonia, and methane are shown here. A diatomic molecule contains only two atoms. Hydrogen, nitrogen, oxygen, bromine, hydrogen chloride, and carbon monoxide are examples. A polyatomic molecule contains more than two atoms. Ozone, water, ammonia, and methane. An ion is an atom or group of atoms that has a net positive or negative charge. A cation is a positively charged ion. If a neutral atom loses one or more electrons, it becomes a cation. Here we have sodium, 11 protons, 11 electrons. By losing an electron, we form sodium plus, 11 protons, 10 electrons. An anion is a negatively charged ion. If a neutral atom gains one or more electrons, it becomes an anion. Chlorine has 17 protons and 17 electrons. Gaining one electron makes it chloride, Cl-, 17 protons, 18 electrons. A monatomic ion contains only one atom. Examples are sodium plus, chloride, calcium, 2+, oxide, aluminum, 3+, and nitride. A polyatomic ion contains more than one atom. Hydroxide, cyanide, ammonia, and nitrate are shown. Some common ions in the periodic table are those of the alkali metals group 1A, alkaline earth metals group 2A, the oxide group 6A, the halogens 7A. Notice that those charges correspond to the group number. In the case of the alkali metals and alkaline earth metals, it's the number of the group. For the nonmetals, if you subtract 8 from the group number, you get the charge on the ion. The ones that are not easy to predict are the transition metals shown in the middle. There you see that they can have multiple charges. Here's a representation of formulas and models. Molecular formula for hydrogen is H2, for water H2O, ammonia NH3, and methane CH4. The structural formula shows the bonds between the atoms. Models like ball and stick show the atoms as balls and the stick as the bond. And the space-filling model shows the atoms without the space between. A molecular formula shows the exact number of atoms of each element in the smallest unit of a substance. An empirical formula shows the simplest whole number ratio of the atoms in the substance. For water, the molecular formula and the empirical formula are the same. Here's glucose. Notice that the empirical formula has to be multiplied by 6 to be able to get to the molecular formula. For ozone, the empirical formula is O. We have to multiply that by a 3. For hydrazine, we have to take the NH2 and multiply it by 2. Ionic compounds consist of a combination of cations and anions. The formula is usually the same as the empirical formula. The sum of the charges on the cation and the anions in each formula unit must be equal to 0. Here's a representation of sodium chloride. At the extreme right you see the actual crystals, which are cubic. And then we have the ball and stick model and the space filling model. Most reactive metals shown here in the periodic table are green, and the most reactive nonmetals are blue. Combining these two, one forms ionic compounds. Let's take a look at some ionic compounds and figure out how one achieves the ratio between the two atoms. For aluminum, we know that aluminum has a 3+ charge, and oxygen forms the oxide 2-. To balance out, we need 2 aluminums for 3 oxygens to get 0. For calcium bromide, calcium is 2+ and bromide is -1. We need 2 bromide for the calcium. For sodium carbonate, this one's a little trickier. Carbonate is 2-, sodium is +1. We need 2 sodiums to balance out the 1 carbonate.